Hi, it's Mr. Bennett here. In today's video we're going to be looking at how 3D cinema works. Alright, so obviously light can be polarised. So if we polarise light, then we can actually allow it to use some special glasses to actually see 3D cinema. And we'll talk about how that's actually filmed as well in today's video, and certainly how you actually view that information. And then we'll also talk about how your sunglasses work. So if you've ever had Polaroid sunglasses, we'll talk about how they work as well. Alright, so polarisation of light. Simply, when light comes in, if you're looking at where the little torch is there, it's got to have light waves coming in all different directions. What you can use is a Polaroid filter to filter out every particular wavelength except one. So this one here is vertically filtered. There. If you have a filter which is vertical and then also horizontal, you end up basically blocking out all of the light. So none of the light will get through there. And you can see the example there where if you imagine having a rope being oscillated through like a picket fence, how you might do that. Alright, so that one there you would see light coming through. Here you would see just black. So here's an example. Light's transmitted when the filters are the same orientation. So you can actually see the lady there. That's when they're at right angles to each other, so it blocks out all the light totally. And then obviously if you put a third polarized filter between the two, you get some interesting patterns you can actually see. So we've got some Polaroid filters I'd like you to play around with in class. So just check that out for yourself. Obviously it's not blocking all the particular light directions. So some of them are getting through, and therefore you can see some of the image on the other side. So when they're making 3D movies, what they will do is they'll have special cameras which have two particular cameras separated by basically almost an eye difference. So they're taking two images at the same time. Right? And if you think about how you see in the real world, right, our eyes are separated and we can see depth due to that fact. Right? So here's something I'd like you to do here is looking at the image basically, with your finger up there, I want you to close your left eye and have a look at the image, and then open your left eye and close your right eye and see how it's actually moved. If you do that, you'll get something a little bit like what's happened here in this diagram. Alright, so with this, basically what you're doing is you're getting at a shift in the image compared to basically where your eyes are seeing from. Alright, so your point of view. If you look at the two pictures here, they're slightly different, aren't they? Alright, so if you can see one image with your left eye and one image with your right eye, that's essentially how 3D cinema is actually made. Right, so what happens here? Right, so if you're looking from above, right, so what we want to do is we want to see an image with our left eye, and we don't want the right eye to see that, we only want to see the left eye to see that image. Alright, so that's basically what happens here. So if that's horizontally polarised, our left eye is horizontally polarised. Our right eye is vertically polarised, and so therefore our vertical polarised glass is there. So therefore what's going to happen for the viewer is that the person sitting there is only going to see the left image with the left eye, the right image with the right eye, and they're both being put onto the screen at the same time. So if you took your glasses off, it would appear to be a little bit blurry, but your brain's quite intelligent, so therefore in terms of looking at the image, it's saying there's not two images there, there's only one image, and it's actually seeing what you're seeing from both of your eyes, putting together to make it look like a 3D image. So that's simply how it works. Polarised eye viewing. Alright, so if we're looking at this scenario here, so which pair of glasses would best suit for a driver? Obviously you're having reflections off the road. So do you think it's A, B, C? I suggest you stop this video and have a bit of a chance to have a think about it. Right? And the answer is pair A. Okay, pair A is best suited to block because only the vertical axes are going to be coming out. All the horizontal reflections off the light, off the road or off the surface is going to be blocked. Obviously, C is going to be only useful for 3D cinema. So really, it was only up to A and B anyway for those two. So in this video, hopefully you've actually understood that you can polarize light and how it's done. Hopefully you understand the very simple way that 3D cinema works, and it's pretty well as simple as what we've explained it today. And then hopefully you understand about polarization and how that needs to work in sunglasses. Obviously with sunglasses you are polarizing the horizontal component, so you're only letting the vertical light come through.